Well, pre-calculus classes, again, good morning, good afternoon, or good evening, whenever you might be watching these. We are going to go ahead and start into the second set of P6 notes. Good news compared with the first set, these are a lot shorter. And in day 2, we're going to go over adding and subtracting rational expressions. In order to add or subtract fractions, they must have, going back to 5th grade, a common denominator. Don't know how much, if any, rational expressions you guys worked with last year towards the tail end of the year in Algebra 2, but this may or may not be something that looks familiar to you guys. If we have x over x minus 3 plus 3 over 2x plus 3, well, the only way that you can get a common denominator within fractions is by multiplying. You can't do anything like, add an x, add a 6 here to make that 2x plus 3. So what we actually will usually end up doing is this denominator has 2x plus 3. So that's what I need here. This fraction needs the x minus 3. Now, as you work through these, one of the things that I will do, well, certainly you do have to distribute when you are adding and subtracting. Now, don't worry about multiplying out the denominator. We do need to multiply out the numerator. So 2x squared plus 3x. Now, one of the things that I will let you do, as you're working, just put the LCD. You don't actually have to write out that full term all the way through unless you choose to. And then 3x minus 9, again, over our LCD. Now, from here, you just add any like terms. Well, 2x squared, 3x plus 3x is 6x, minus 9 over 2x plus 3, x minus 3. Now, the one thing that you should always at least check is, will this factor? If it does, there is the chance sometimes that things will be able to be simplified. So, you can always check, okay, multiplies to negative 18, adds to 6. Well, that's not going to factor. So, there is addition. The only other thing, sometimes you might be asked for restrictions. Certainly not a bad thing to go back and talk about that a little bit. Subtract the 3, divide by 2, so x could not equal negative 3/2 or 3. Sometimes when you're adding and subtracting, they'll ask you for these. Sometimes they won't. It just kind of depends on the problem. All right, so another one of these. Now, one of the other things that I actually like doing when there is a minus, I actually like making this plus a negative, and you'll see the reason for that here in a moment. Well, for this first fraction, we are going to need x plus 5. For our second fraction, x minus 2. So when we distribute 2x squared plus 10x over our LCD, and again, the reason why I actually like making this plus a negative is when you distribute through, that negative makes the final term positive. And so, that's one of those things that saves you a minor error here and there. So from here now, just combine your like terms. So 2x squared, 6x, 8 over, again, do not write LCD in your answer. Now let's see, multiplies to 16, adds to 6, not possible. So that truly is our final answer. Other than that, again, if you do want to include the restrictions, x could not equal negative 5 or 2. All right, one final adding or subtracting problem. Now we have one where there are 3. Now the one thing that you do want to always do, if you can factor a denominator, do that. Because usually what ends up occurring is you're going to be able to have components of this as your LCD. So here I've got an x minus 1 and here an x minus 1. We do need an x plus 1 and an x. For this one, now here, since the only thing I have is the x, I am going to go ahead and go back and just use the distributed x squared minus 1 here for my denominator. I will go ahead and leave it factored, and then for this one, I need an x. All right, so with what we have, and here I'm going to actually put the x there, distribute, so 3x squared plus 3x over our LCD. Again, I'm even going to make that plus negative 2, so negative 2x squared plus 2, again over our LCD, and then plus x squared plus 3x over our LCD. So we have 3x squared minus 2x squared plus x squared is 2x squared. 3x and 3x is 6x and 2 over, and here's where I'll kind of leave it up to you, either over x, x minus 1, x plus 1. Certainly if you would have wanted to say x squared minus 1 with that, perfectly fine. And multiplies to 4, adds to 6, does not happen. Your restrictions, x cannot equal 0, and positive and negative 1. So again, as I mentioned, day 2's notes a lot shorter than what we did for day 1. But there is adding and subtracting rational expressions for P6.